You take a probiotic pill hoping it fixes your gut. You swallow it fast, barely thinking about what's actually inside. But somewhere right now, a scientist is doing almost the exact same thing for a sick dolphin. And what they are using instead of a probiotic capsule is far stranger and far more effective. It's called a fecal microbiota transplant. Poop essentially moved from one healthy animal into a sick one. It sounds absurd. But inside that transplant is an entire invisible ecosystem, trillions of bacteria that control digestion, immune defense, and have increasingly been linked to mood. Lose the right ones and an animal can starve on a full stomach. So what happens when you put them back? Start with the dolphins. Bottlenose dolphins in professional care sometimes develop stubborn gastrointestinal disease, a gut thrown so far out of balance that antibiotics alone can't fix it. Researchers working with the US Navy Marine Mammal Program and the National Marine Mammal Foundation tested something simple. Take the gut microbes from a healthy dolphin and transplant them into a sick one. It worked. The transplants proved safe, and they meaningfully improved outcomes in dolphins struggling with gut disease and microbial imbalance. It's not medicine in the traditional sense, it's an ecosystem repair job. Now picture a koala. Koalas eat eucalyptus, but not just any eucalyptus. Each koala's gut microbes are tuned to specific species, like a lock built for one particular key. Move a koala to a new forest, and it may starve surrounded by leaves, because its gut simply can't break them down. Researcher Michaela Blyton and her team tested something bold. They took gut bacteria from koalas that ate a wider range of eucalyptus and transplanted it into koalas that only tolerated one type. Over the following weeks, the more a koala's microbiome shifted toward its donors, the more of the new eucalyptus it ate. A koala's diet, it turns out, isn't just preference, it's microbiology. And if you can rewrite the microbiome, can you rewrite what an animal is even able to survive on? Then there are cheetahs. Captive cheetahs are notoriously fragile, prone to gut disease, and often need antibiotics that wipe out their microbiome along with the infection. Biologist Sally Bornbush and colleagues tried something clever, banking a cheetah's own healthy gut bacteria before treatment, then transplanting it back into the same animal after a round of antibiotics. It worked. Recovery sped up, fewer complications, a better shot at the kind of long-term health that captive breeding programs desperately need, because cheetahs are already among the hardest animals on Earth to breed and release. Here's the pattern across every one of these stories. A struggling animal has a damaged gut community. Healthy gut bacteria get introduced, sometimes from another animal, sometimes banked from the animal's own healthier past self. The system rebuilds itself from the inside out. Simple mechanism, strange delivery method, real results. Human medicine got here first, actually. Fecal transplants have been used for years to treat a stubborn human gut infection called C. diff, restoring the microbial balance antibiotics had wiped out. Conservationists just borrowed the idea and pointed it at koalas, cheetahs, dolphins, and researchers are now exploring it in pandas and meerkats too. It's the kind of idea that sounds almost too simple. Everything poops, so why not use it? It's easy to laugh at the premise. Poop pills for wildlife sounds like satire. But look past the punchline and there's something genuinely moving here. A field of scientists deciding that the smallest, least glamorous part of an animal, the part nobody wants to think about, might be the key to saving it. Not a vaccine, not a cage redesign, a transplant of microscopic life, quietly rebuilding what captivity and illness tore apart. So the next time you swallow a probiotic, remember there's a scientist in a marine mammal facility somewhere doing the same thing for a dolphin, just stranger and more effective. If you enjoy hearing stories about the microbiome, click here to watch a previous one we made.